Use the algebraic formulas of finite sums to evaluate the following. So let's simplify our argument here so we can see those formulas. We have the sum from k is 1 to 6. And so looking at this, I'm going to distribute this k through to both terms. So the general formula becomes 2k squared plus 9k. And now looking at this sum, we think, oh, we have the sum of these two terms. So we can apply the sum or difference formula, or by the sum or difference rule, we can rewrite this as the sum from k is 1 to 6 of 2k squared plus the sum from k is 1 to 6 of 9k. And now looking at these two sums here, if we look at the first term, we think, oh, we've got a constant 2 in the front. If we look at our second sum, we have a constant 9 in the front. So we can say, by the constant multiple rule, we can rewrite this even further. We can say that this is equivalent to 2 multiplied by the sum from k is 1 to 6 of k squared plus 9 multiplied by the sum from k is 1 to 6 of k. And now looking at these two, we realize, oh, we've got another formula. So if we look at our first sum here, this is the sum of the first n squares, or not n, see we have a finite value here, we have 6. So this is the sum of the first 6 squares. And then with our second term here, can we notice we have this k? So this is going to be the sum of the first, again looking at your upper bound, this is going to be the sum of the first 6 integers. So let's go ahead and apply those formulas. Again, we can keep in mind that we know that that's the sum from k is 1 to n of k squared, which simplifies to n times n plus 1 times 2n plus 1 divided by 6. And so thinking about the sum of the first n integers, we know that that is defined as the sum from k is 1 to n of k, which we know simplifies to n times n plus 1 divided by 2. And now again here, because we have a specific number versus n, we're going to replace each of the n's in these formulas with 6. So let's go ahead and do this. All right, so here we go. So our first term, we have 2, and this is going to become, again, we're applying the sum of the first 6 squares. So this will be 6 multiplied by 6 plus 1 multiplied by 2 times 6 plus 1, and that's all divided by 6, plus 9 multiplied by, and now again we're applying this general formula for the sum of the first 6 integers. So this will be 9 multiplied by 6 times 6 plus 1, all divided by 2. And we have some nice simplification here, so we can see those 6's cancel each other out. We know that 2 goes into 6 3 times. So this is equal to 2 multiplied by 7 times, then we have 12 plus 1 is 13, plus 9 multiplied by 3 times 6 plus 1 is 7. So we have 2 multiplied by 7 times 13 is 91, plus 9 times 21. So we have 2 times 91, which gives us 182, plus 9 times 21, which is 189, for a beautiful final answer of 371.